All right, so this is Unit 3 of our review for the milestones. And Unit 3 was on geometric applications of exponents. So after we learned about exponents in Unit 2, we went on to Unit 3 and then used our new knowledge of exponents to work with Pythagorean Theorem and also volume. So this video is going to review you with those two things. So first up, let's start with Pythagorean Theorem. All right, so Pythagorean Theorem is true for all right triangles, and what it says is that a squared plus b squared equals c squared. Well-known formula in algebra. You might be wondering, what are a, b, and c? Well, it's a good question. So a and b are the sides of the right triangle that make up the legs. And if you think about it, the L, which is what legs, L, that's where the right triangle is, and that's where the A and the B are. It really doesn't matter which one's A and which one's B, but those are the two sides that make up the legs. The side that's called C is the one that is across from the right angle, and that's known as the hypotenuse, which in a right triangle is always the longest side. So the longest side is the hypotenuse. So when we have a triangle, you might know that, let's say maybe this side is 9, and then maybe this side is 5. And you might be asked to figure out what side C is. So what we're going to do is just fill this into our formula. So a squared means 5 squared plus b squared, which would be 9 squared, equals this side squared, which would be c squared. All right, well, let's do what we can. So we know 5 squared is 25, and 9 squared is 81. I can add those together and get 106. So now what I know is that c squared is 106, which means that c must equal the square root of 106. Now, something else that we learned in Unit 2 was how to estimate square roots to the nearest tenth. So in this case, we could leave our answer as the square root of 6 if that's an option, or we can estimate it. So what I know about the square root of 106 is that it's bigger than 10, but it's smaller than 11. So I know it's going to be 10 point something. All right, so if we think about it, so here is the square root of 100, which would be 10, and here is 11, which would be the square root of 121. I know that the square root of 106 is kind of down here somewhere. So I might say maybe this is about 10.3, because that looks about a third of the way over. All right, now, something else that happens with Pythagorean Theorem is that maybe we know what side C is, and we have to figure out A or B. So let's just pretend for this example. So I'm going to draw a little line there. All right, let's say that we knew that A was 3 and C is, oh, I don't know. How about C can be 7? So what we don't know is B. Well, we can still use the same formula. So A squared would be 3 squared plus B squared equals C squared, which would be 7. All right, so let's do what we can. We know what 3 squared is, so 9 plus b squared, and I know 7 squared is 49. All right, I need to figure out b, so let's subtract 9 from both sides. So now we know that b squared is equal to 40, which means b would have to be the square root of 40. So at this point, if square root is an option for an answer, I could leave it like that, or I can estimate it. So what I know about the square root of 40 is that it's bigger than 6, but smaller than 7. So I know it's going to be 6 point something. So let's sketch this out and think about it. So here is the square root of 36, and here is the square root of 49. So that would be 6, and that would be 7. And the square root of 40 is going to be a lot closer to this side than it is to that side. So I might say maybe 6.3 again. All right, now you might be wondering how this even works and what does this mean and everything else. So when I taught this, I used Skittles to show you guys that if we actually created a square off of each side, then the Skittles would be the same. And so I'm just going to kind of sketch this out. So let's just say that this side right here is 3. If I literally make a square on this side right here, then this side would have 9, or this box would have 9 Skittles in it, because I would have, and maybe I'll use pencil for this, I would have 3 going across, but if I have to make a square, that means I also have to have 3 going down, which in total gives me 9 Skittles. All right, let's say this side over here is 4. So if I made a square out of this side, whoops, I'm going to try anyways. Oh my gosh. Okay, that was awful, but I'm using my erasable pens here, so that one's pretty bad. But if I make a square on this side, how many Skittles would I take? Well, since this is 4, and I have to make a square, that means I need 4 this way, and 4 by 4 would mean this side right here would have 16 Skittles in it. All right, well, we have one more side. So I'm going to go over here, and let's say this side is 5. So if I make a square, which I can't make a square when it looks crooked to me, so I'm going to have to go like this. Oh my gosh, that's terrible, but we'll just pretend. All right, so this has 5 on it. And if it's a square, that means this has to have 5. And 5 by 5 means that I have 25 Skittles on this side. So this one has 25 Skittles on it. Well, this is where Pythagorean Theorem ended up coming from. So what happens is I take this side, which I'm going to call is A, and I made a square out of it. And this side over here, which I'm going to call B, and I made literally a square out of it. If I add those two together, it equals the same amount that I got when I made a square out of that side. So that's what Pythagorean theorem literally means. All right, next up. Find a right triangle within a word problem is how we apply Pythagorean theorem. So let's just say that there is a tree and we have a little cat up in the tree. All right, so we need to figure out how we can get this cat out of the tree here. So we need a ladder. So here's my ladder. All right, so I don't know how high up the ladder or how up the tree that the cat is, but let's just say that we're using a 10-foot ladder, okay? And let's say that I place the ladder, let's say I place the ladder exactly 6 feet from the base of the tree, okay? Now, this is a three-dimensional drawing that doesn't look three-dimensional at all, so let's just pretend. All right, so my question is, how high up the tree did the cat go? Well, look at what happens here. I end up with a right triangle. So between the ladder, the ground, and how high the cat went up the tree, I have a right triangle. So I'm trying to figure out how high up the tree the cat went. So if I look at this situation, I can use Pythagorean Theorem. So remember that the A and the B are the legs. So I'm going to say A squared plus B squared equals C squared. So I knew that these sides had to be the A and the B. So I just filled in what I knew. All right, well, let's see what we can do. Well, we know that's 36. I don't know what h squared is. I know that's 100. If I work to solve this like an equation, then I know that has to be 64. So the height would have to be the square root of 64, and that happens to be perfect. So I know that the cat is 8 feet in the air. All right, another use of Pythagorean Theorem that's very cool is that we can use Pythagorean Theorem to find the distance between 2 points that are on a graph. So I'm just going to plot 2 points. So I'm going to say this one and this one. So let's say that I'm trying to figure out how far away those 2 points are from each other. Well, you can't really count diagonal measurements here because I have no idea how to make those into fractions or decimals of a space. But what I can do is make this into a right triangle and then use Pythagorean Theorem to figure out this length right here. So I know by counting right here that this is 1, 2, 3, 4. And then I know by counting here, this is 1, 2, 3, 4, 5. So now I can use Pythagorean Theorem to figure out the length of that side. So to do the work, I know that the 4 and the 5 are my A and B. So I'm looking to figure out the C. So A squared plus B squared equals the missing side squared. So let's see, that's 16, that's 25. If I add those together, I get 41 for C squared, which means that C is the square root of 41. And again, I could leave that as my answer if square root was an option, or I can estimate it. So if I think about 41, I know it's going to be 6 point something, and I know that because the square root of 36 would be 6, and the square root of 49 would be 7, and the square root of 41 is somewhere in the middle of those two. Let's see, if I had to place 41 on here, 41 is a little bit closer to 36 than it is to 49. So I might say 6.4. All right. So I'm going to pause this video and then start a second video to cover volume.